From this first step of the division, we have written this first part of the Euclid's lemma. Now seeing the second step of the division, we'll write the next step. That is 135 is the dividend, 90 is the divisor, 1 is the quotient and 45 is the remainder. According to the second step of division, we've written this second part of lemma. Then as per the third part of the division, we will write 90 as the dividend, 45 as the divisor, 2 as the quotient and 0 as the remainder. Now you will see here very carefully that the divisor which is there in the last step, that is your HCF. So you will write here HCF of 135 and 225 is equal to 45. This is a method of writing the HCF. HCF is also known as GCD. Greatest common divisor term can also be used for HCF. Now this way we can use Euclid's division lemma to find the HCF of the numbers. Next very important topic which is there with us is fundamental theorem of arithmetic. Now as per the statement, it says every composite number can be expressed as product of primes. Now you know that we have two types of numbers, primes and composites. The composites number are having more than two factors. Prime numbers are having only two factors, that is 1 and itself, whereas composite numbers have more than two factors. Now if you have a composite number, you can always factorize it and write it as a product of primes. This factorization is unique apart from the orders in which the prime factors occurs. Now this is very important. We'll understand it with the help of an example. Just say you have 30. You have a number 30. I can factorize it like this: 2, 15, 3, 5. That means 30 can be written as 2 into 3 into 5. Now if I ask some other child to factorize it, it can be done in this way also. 3 10s are, 2 5s are. Now this way 30 can be written as 3 into 2 into 5. Or some other child can start the factorization with 5 and write it this way. Herein 30 can be written as 5 into 3 into 2. No matter who is factorizing this number, we are always getting three factors, that is 2, 3 and 5. But their order varies. Herein we have the first factor as 2. Herein we have 3 as the first factor. Here the 5 as the first factor. Just see these three. All the prime factors are same, but their order is changed. So this is fundamental theorem of arithmetic, that we can always express this composite number as a product of primes, but this prime factorization can have a varied order. Now this fundamental theorem or this prime factorization process can be used to find the HCF and LCM of the numbers. So you have taken a question over here, find the HCF and LCM of 336 and 54. Also verify that HCF into LCM is equals to product of two numbers. Now this verification process, LCM into HCF is equals to product of two numbers, this is valid only for two numbers. Please be careful, this is valid only for two numbers. Now I've taken 336, I've already factorized it. Same way 54 I've already factorized. I can write it as 2 into 2 into 2 into 2, 4 times 2, and then I have 3. Always express it in the power notation. 2 raised to the power 4, 3 raised to the power 1. Same way 54 can be written as 2 into 3 times 3. Again express it as the power notation so that it is easy to work out then. Now we need to find their LCM and HCF. Just be careful, while writing HCF, you have to look for the common factors. Herein 2 is common. See, herein we have 7 also. In 336, one of the factor is 7 also. So we are going to write it along. And while writing the HCF, we have to look for only common factors. Now 2 is common, 3 is common. With lowest powers. Amongst the two powers, the lowest power is 1. Same way for the powers of 3, the lowest power is 1. So HCF is 6. While writing LCM, you have to write all the prime factors with the highest powers. Now see, power of 2, highest power is 4, 3, 1. Now if you calculate, you are going to get 3024 as the LCM and 6 as the HCF. Now comes the verification part. We have to verify LCM into HCF is equals to product of two numbers. Now what we are going to do here is, left hand side is LCM into HCF. So if you write 3024 into 6, you are going to get 18144. And right hand side, if you are going to find the product of two numbers, you are going to get 336 into 54, which is again 18144. So left hand side comes out to be equal to right hand side. This is verified. While doing the verification, you always have to solve the left hand side and right hand side separately. Coming to the next question, find the LCM and HCF of 12, 15 and 21. Now in this question we are having three numbers. Again we will follow the same procedure of finding their prime factors first. 12 can be written as 2 square into 3. 15 can be written as 3 into 5 and 21 can be written as 3 into 7. For finding the HCF, just look for the common factor. See, 3 is a common prime number amongst the three numbers given. So this is the HCF. For writing LCM, we need to write all the prime factors. See, we are having 2, 3, 5 and 7. Write down all the prime factors with highest powers. Now 2 is having square with it. 3, 5, 7 all are having power 1. So if we solve it, we are going to get 420, which is our LCM. Same procedure will be followed for two numbers as well as three numbers to find their HCF and LCM. Another type of question which we are having, explain why 7 into 11 into 13 plus 13 is a composite number. Now in order to show that it is a composite number, we have a very simple procedure. If we are able to show that this is having more than two factors, then automatically it will be a composite number. Just see how can we show that. We have 7 into 11 into 13 plus 13. Now see, this number is having two terms, and amongst these two terms 13 is a common number. So 13 can be taken out as a common number and we can write the remaining number in the bracket. Now we get 13 into 7 into 11 into 1, that is 77, plus 1, that is 78. Now 13 into 78. These two are the factors of the given number. Moreover, 1 is also the factor of the given number. So clearly I can see three factors here. More than three factors are also possible, but herein I can clearly see three factors. So a composite number has more than two factors. Therefore, it is a composite number because it has more than two factors. Whenever you are able to show that the number has more than two factors, therefore it becomes a composite number. Thank you.